Okay, Advanced Math, this is my first lesson that I'm videotaping. So, it may or may not be chronologically the first one, but it is the first one physically that I'm doing here. So, before I get started here, we will talk about this section here, graphs of tangent, cotangent, secant, and cosecant functions. While I'm out for paternity leave, I'm going to try to leave quite a few videos. I don't know how many I'll get to, but if they're not me speaking, I might try to get videos off YouTube. And if you ever have any questions, well, I'm gonna have you guys try to. I haven't done it yet, but by the time of this video, by the time you watch this, hopefully you guys will be signed up for Google Classroom, so you can go back and rewatch videos. You can ask questions. You can make a comment on a video. Or on the Google Classrooms page. I'll try to get to questions. Mr. Frazier, who will be in here Mondays and Tuesdays, I believe, you can ask him. He's a retired engineer, so he knows what he's talking about math-wise. So you can ask him, or you can ask your classmates. Rely on your classmates, guys. I'm sure if you have a question, there might be somebody in the class that knows the answer. If not, that's the time to ask. Try to ask me through Google Classroom, or try to ask Mr. Frazier. So, whenever you need to pause these videos, do so. Okay. I'm going to try to make the videos short, so I might move fast. So just be aware of that. So here we go. Let's get started. So the way I'm going to graph these functions, we're just going to try to. This video is just going to be just basics, trying to understand essentially what tangent looks like, the graph of tangent, the graph of cotangent, and the other two as well, secant and cosecant. So I'm going to try to run through these. I've got the unit circle pulled up as well, so that's what we're going to use. We're not going to just rely on the calculator. Let's use a unit circle. Let's try to figure these out by hand, what these tangent values are. Okay, so the way we're going to do it is just like when you guys first started graphing things, you just pick points. It's usually the easiest way to get graphing started. So let's go ahead and pick some points here, and I've got these points. If I were you, draw this picture as well. Draw the coordinate plane and label it how I have it labeled. But I'm going to go and scroll down here, so pause it if you need to label it. So here it is. Here's the graph. Start drawing that. And the values I'm going to choose, I could choose as many values as I wanted to, guys. I'm just going to pick 5, just so you guys get a good idea, and then I'll show you what the graphs look like because of that. So. I think 5 will be good enough. Like I said, you can keep going. Hopefully we'll get the idea with these 5. So let's get started. Let's first start with pi over 2. So essentially what we're trying to do, we're trying to figure out what is the tangent, not pi over 2, negative pi over 2. What is the tangent of negative pi over 2? So what I'm going to do is I'm going to bring up my unit circle. Actually, before that, remember tangent is what over what in general. It's, well, you can think opposite over adjacent if you're dealing with right triangle trig. But it is sine over cosine. So we need to figure out the sine of negative pi over 2 over the cosine of negative pi over 2. Alright, so let's start with sine of negative pi over 2. Alright, so hopefully you guys are aware by now that negative pi over 2 is going to end up down here. Alright, at the same position as 3 pi over 2. So rather than opening up counterclockwise all the way to 3 pi over 2, you go this direction, negative pi over 2. Alright, so here's the point that we're looking at. So remember, sine doesn't deal with x or y values. And the answer is x. Sine is always the x value of that point. No, I got it wrong. Okay, sorry. I'm not going to edit this. Okay, I messed it up. So sine is the y values. Okay, so we picked the y value of that point. So what is the y value of that point? The answer is, anybody? Yeah, negative 1. So let me go ahead and flip back to this. So the top is going to be negative 1. The bottom, well, the cosine of pi over 2, let's go back to that. What is the x value of that point? Hopefully you guys see the x value is, that's right, 0. So guys, we got negative 1 divided by 0. Is that possible? Are we allowed to divide by 0? The answer is no. So this answer is undefined. Undefined. So guys, if something is undefined in our graph, it is either going to be a hole in the graph or an asymptote. Okay? And in this case, it's going to be an asymptote. So we are going to get an asymptote at negative pi over 2. So let me go and try to find that. Negative pi over 2 would be halfway in between that. Negative pi over 2. And that is going to be a vertical asymptote because it's undefined there. All right, let's keep it rolling. The next one is negative pi over 4. Let me do this in red. So if we want to find the tangent of negative pi over 4, that is the same thing as sine of negative pi over 4 over cosine of negative pi over 4. So let's walk through this. So the sine of negative pi over 4, first of all, let's find negative pi over 4 on our unit circle. Let's do that first. So negative pi over 4, now again, instead of going this direction, pi over 4 radians, we want to go the opposite direction. We want to open clockwise. So if we only go pi over 4 radians, that's going to be the same position as 7 pi over 4. So this point right here, now we've talked about this, I will have talked about this, is that, okay, so we're talking about sine values. So remember, sine values deal with y values. So is that the biggest y value? When I say biggest, I mean the biggest absolute value y value. Is that the middle y value, or is that the smallest y value? And the answer is, it's the middle y value. So remember the important values that we talked about, 1/2 square root of 2 over 2 and square root of 3 over 2. The middle value is square root of 2 over 2. Now, isn't that y value also negative? So guys, the sine of negative pi over 4 is going to be negative square root of 2 over 2. There we go. The cosine of pi over 4. Well, it's going to be the same thing in terms of value. I mean, in terms of absolute value is what I meant to say. So is this point right here, think of the x-coordinate there, is that the smallest x-coordinate, the middle one, or the biggest one? And the answer is the middle one again. And by the way, that's a positive x value, so therefore it's going to be positive square root of 2 over 2. Alright, so hopefully we've had a lot of practice with this. Hopefully this makes sense. This is positive square root of 2 over 2. So guys, we've got the same thing being divided by itself. So anything divided by itself other than 0 is 1, but we still have this negative here. So the answer here is going to be negative 1. Okay, so let's plot that point. So to plot this point, and by the way, negative pi over 4 would be halfway in between 0 and negative pi over 2. That would be the point 1. Okay. Sorry, my bad. Misspoke. Negative 1. Okay, let's keep going. Let's do 0. So let me do this one in purple. The tangent of 0 radians, or 0 degrees, but in this we're using radians here. So it's going to be sine of 0 over cosine of 0. Okay, so let's look at sine. Let's look at the unit circle first. Right here is our point. So that point right there, that's 0. 0 radians / 0 degrees. So what is the y value of that point? What is the sine value of that point? The answer is 0. Sine, it doesn't go up at all, so the y value is 0. Okay. What is the cosine of 0 degrees? Well, cosine is x value. So what is the x value of that point? And the answer is 1. So what's 0 divided by 1, guys? Answer 0. So I'm gonna use red here on my graph. So at 0, my answer is 0. So fill in that point right there. Okay. I'm just trying to decide whether I'm going to go ahead and answer these guys. You guys try these on your own. So figure out the tangent of pi over 4. The answer to the tangent of pi over 4 is going to be 1. And then the answer to the tangent of pi over 2, that's going to be undefined again. Alright, so you guys try those on your own. If you need to pause it, go ahead. But hopefully that makes sense. So, at pi over 4, which would be about right here, okay, that's going to be the point 1. And then at pi over 2, which would be about halfway in between pi and 0, that is going to be another asymptote because it's undefined there. So hopefully you guys can visualize what's going to happen here. It's got to behave asymptotically. My graph is going to look like this. Oh, that was bad. Let me fix this. Something like that. Okay. Now, if you want to get more precise, you could include more points there. We could find tangent of pi over 6, negative pi over 6, pi over 3, negative pi over 3. But I think that's good enough. Hopefully that's all right with everybody. So that would be what the graph would look like from negative pi over 2 to pi over 2. And just so you guys know, I'm going to write this down in a second, but we're going to have asymptotes at all odd multiples of pi over 2. Okay? So this is negative 1 pi over 2. This is positive 1 pi over 2. The next asymptote is going to be 3 pi over 2. The next asymptote would be 5 pi over 2. So hopefully you guys see what I mean by odd multiples of pi over 2. Okay? That would be the next asymptote. And then guys, again, you could find all these points, but I'm trying to speed things up here so the video is not so long. All these values, it's just going to repeat over and over. So just like sine and cosine repeat every 2 pi. Tangent's going to repeat, but instead of every 2 pi, it's going to repeat every pi units. So guys, think about this. What's the length? How long does it take for this cycle to repeat itself? Well, what's the distance between negative pi over 2 and pi over 2? And the answer is pi. Okay, there's pi over 2 units here, there's pi over 2 units here. Pi over 2 plus pi over 2 is going to be 2 pi over 2, which reduces to pi. So the length, we call it the wavelength with sine and cosine, otherwise known as the period. This isn't really a wave, but the period of this is going to be pi units. Okay, so from there to there, it's pi units. And it's just going to keep repeating forever. All right, so it's going to repeat this way. It's also going to repeat going back this way. And I didn't draw it the best, but you guys get the idea. So that's what tangent's going to look like. Now let me make a couple of notes here before I move on. Okay? So, let's just say y equals tangent of x. Has asymptotes, let's say vertical asymptotes. Okay? At odd multiples of pi over 2. Okay. Let me write the next thing down. Another thing to note is that notice where the zeros are. Okay. By zeros, I mean x-intercepts. So notice where the x-intercepts are. They're at 0, pi. It's supposed to be at 2 pi. I didn't draw it the best, but it's supposed to be at 2 pi. So they're at multiples of pi. So y equals tan x has zeros at not odd multiples of pi, but multiples of pi. And just so you have your notes, so 0, pi, 2 pi, dot, dot, dot. Okay. And then the last thing that I want to mention, the period. Remember, the period is how long it takes to repeat. Is pi units. So it only takes pi units for tangent to repeat. Remember, with sine and cosine, it takes 2 pi units for it to repeat. All right, so that's a good rough sketch of the tangent function. All right, let's move on to cotangent. You'll notice a lot of similarities here. It looks similar. There's going to be some differences. All right, so let's look at these. So let's do cotangent next. I'm going to move on. If you need to pause, go ahead and do so. Alright, so pause it here and pretty much draw the same graph, guys. And just draw a rough sketch of it. I'm going to do exactly the same thing. I'm going to just pick some points and figure out what cotangent is of these values. So here goes. Let me scroll down. So let's figure out what the cotangent of negative pi over 2 is. Now remember, if you remember this, cotangent is the reciprocal of tangent. We said tangent was sine over cosine, So that means cotangent is cosine over sine. So how about, why don't we just cheat, guys, and use the values that we did last time? So what did we say sine was? Well, let's do cosine first. We said cosine was 0, didn't we? Okay. And then we said sine is -1. So what if we flip those? Well, it would be 0 over -1. Do that real quick. And what's 0 divided by -1? The answer is 0. Okay. And so, yeah, why don't we just cheat for all of them? So just flip them, basically. It'd be a little bit quicker that way, hopefully. So this guy right here, well, it wouldn't really matter if we flipped them. They're the same, except one of them's negative. So if I took the square root of 2 over 2, divided by negative square root of 2 over 2, my answer is still -1. Okay? Let's keep going. 0. So cotangent of 0, well, again, how about let's cheat it. Not really cheating, we're just working smarter, not harder. So, tangent of 0 was 0 over 1, so the cotangent would be that flipped, so it'd be 1 over 0. What's 1 divided by 0, guys? That's right. Oh, come on. Undefined. It's undefined. Pi over 4. We've done it already. The tangent of pi over 4 was 1, so if we flip 1, it's still 1. And then pi over 2, let's go back to pi over 2. We said this was undefined, the tangent of pi over 2. So if that's undefined, that's something divided by 0. So if we flip it, it'd be 0 divided by something. 0 divided by something is 0. Okay, so let me try to plot all these real quick. Here we go. So first of all, let me plot, here, let me do negative pi over 2, would be about right there. And positive pi over 2, would be about right there. I might need to do some more points here. But let me go ahead and plot, negative pi over 2 is 0. So let me do this in red. Scroll down. Negative pi over 4, the y value is -1. There we go. My bad. Dang it, messed up. I need to do pi over 4, negative pi over 4. Which would be about right there. So here we go. Sorry about that if you wrote that down already. So we got that. Now, the next thing is that this is going to be undefined at 0. Okay, so if it's undefined, what's that going to look like? Hopefully you guys told me it's an asymptote. So it's going to have a vertical asymptote there. Now at pi over 4, which would be halfway between pi over 2 and 0, what do we say the value is? Pi over 4, the answer is +1. Okay. So let's plot that. At pi over 2, the answer is 0. Guys, I could keep going, but we're just plotting these points here. Hopefully you guys can see what's going to happen here. Our asymptotes are going to be at multiples of pi. Okay, so let me write that down. Let me draw all these. And so 2 pi would be an asymptote as well. Negative pi would be an asymptote. And what's going to happen? This is going to behave asymptotically, so our graph is going to look something like this. It's going to keep repeating. That wasn't very good. That was supposed to be at 3 pi over 2. But, hopefully you guys get the idea. So that's the graph of cotangent. So here we go. Let me write down a couple facts here. Y equals cotangent x has vertical asymptotes at multiples of pi. So y equals cotangent of x zeros at odd multiples of pi over 2. Okay. Hopefully you can see that. So the zeros are going to be here, here. The next one would be 3 pi over 2. The next one would be 5 pi over 2. Okay. And then the last thing is the period again. Let me just abbreviate this. So the period is pi. Okay. Period of cotangent. All right, moving on. Let's see. Man, it's been 20 minutes. I'm gonna stop right there. And I'll finish this up next video. Thanks.